Hello everybody, welcome to week 2 where our subject is data formats and how to load data into SAS, which is one of the first things you have to do before you can analyze the data. So we have to discuss data formats, and in data formats we discuss this at a pretty high level, and that is data comes in two formats. The first is called text, and text data is sometimes called ASCII. The American Standard Code for Information Exchange. Oftentimes they call these flat files. These have been around forever, and now they are taking a great deal more precedence with respect to the big data because a lot of data is stored in flat files. In text format, text files can be easily viewed using any text browser, such as Notepad, Notepad Plus, or Ultra Edit, which is my favorite. It's a really very powerful tool. They are defined by the delimiter, which defines how different data elements are separated in a file. So here's an example of a comma delimited file. Oftentimes you will hear things called comma separated or a CSV file in Excel. And here it shows you the first row is the header, and then the first piece of data here is going to be Smith, comma J. This is going to be a text, so it's enclosed in double quotes. Comma says that's the end of the first variable field. Let's go to the second. The next value is 1261, which is going to get assigned to the variable name A. When you load this, 201 to B, 1060 to C, and so forth. Text data elements, for example, in name, are enclosed in double quotes, while numeric values are not. As you can see from this, each data element is separated from a comma. In this example, there are 8 data elements, specifically the variable name, and then A, B, C, on through G. Comma separated are very popular. You'll notice that the comma in the name did not cause this to go to another field because we had text double quotes around that. Here's an example of a space delimited. In a space delimited file, instead of having commas, you're going to have a space, and it will say when you hit a space, not this one because it's enclosed in double quotes, when you hit a space, that means whatever you see next is going to be the value assigned to that next variable. You have to be really careful because if this variable is going to be defined as numeric and you put a string in here, you can have some problems. So the space character is going to be used to delimit. There are also tab delimited files. This double greater than sign that you see is actually an ASCII character. So when you are putting this together in a text file, you literally type double quote Smith, comma J, double quote, then you would hit your tab key and enter 1261, tab 201, and so forth. So here you have the tab character. As a general rule, the tab character is hidden to the naked eye unless you use a viewer like Ultra Edit. Another very common delimiter is called the pipe delimiter, and it looks like a vertical line here. That is over on my keyboard above the enter key. Directly above it, you have to hold the shift and hit the key right above the enter key. Most of your statistical packages today, SAS primarily, SPSS, Minitab, and Alteryx, will readily read these files and load the data in their respective applications. They do it very, very easily. Some of these packages will preview the file, and it will try to interpret the proper delimiter and either load the data contents or prompt the user to confirm the appropriate delimiter. This is also done in SAS. One thing to remember in SAS, let's go back up here just for a second. Now, SAS will, when you import data into SAS will read the first 10, 15, 20, even up to 100 rows to determine what the delimiter value should be. So it will look at this and it will say, I'm sorry, I said delimiter value, the field value. So if you have a bunch of blank values in where should be column A, SAS will think that the data is text for missing, and then you try to enter, when it does hit a number, it will interpret it as a text value that looks like a numeric. So if you have any of these columns that contained a lot of missing values for the rows, I would recommend that you sort this so that you've got very few missing values. Pros and cons of using a text file. One of the pros is that the data files are very easy to edit and view. They can be read very easily and quickly, and the data can be compressed. Sometimes it saves 80% of the file size, especially if you go back up to here. You can see there's a lot of empty space in there. So when you use a compression program like WinZip, it will compress that significantly. Some of the cons, it does not allow for a data hierarchy. Since they're flat files, you don't have a data structure to it, like as in a hierarchy. It's easy for the entire file to become corrupted. So what happens sometimes, for example, if you see this fourth row here, if it becomes corrupted, it can corrupt the entire file. That's bad. When you are accessing flat files, the entire contents have to be loaded unless you have a specific ability in your program to tell it to read only the top 100 or so. The other data format is called binary. Data in binary files can be used, viewed using a text browser such as Notepad and so forth, but the files are not legible. You can look at it, but it looks like garbage. Here's an example of a binary file being viewed using Notepad. See, it's a bunch of nulls, just a lot of stuff in here. End of text, start of text. Very, very difficult to read, so you can't really make it out. Binary files come in a lot of different formats. One that you're very familiar with is MS Excel. Another one is any kind of proprietary statistical package format. When you see a SAS7B DAT, that's a SAS file. YMXB is a Alteryx file. SAVs, I think, are SPSS and so forth. Corporate databases, for example, Microsoft SQL, Oracle, DB2, Netezza, and so forth. Most statistical packages that I mentioned will access these file formats and will load the data in those files into the respective application using a data exchange format capability. Sometimes you hear this called a software driver. All forms of binary files can be read using an open database connectivity software driver. So this thing's called ODBC, and there's different versions of ODBC as well, some that are much more efficient. Some forms of the binary files have proprietary software drivers that access their native data more efficiently. Some of the software packages, like SAS, offer what's called an access engine, and that acts as a universal translator, using a Star Trek reference, for binary data formats. One side of the access engine reads the native format, Oracle, DB2, whatever. The other side of the engine produces output in the application. So one side is reading Oracle, the other side is reading SAS. Some of the pros and cons of using a binary file. Pros: the data allows for a data hierarchy, a relational database. The data elements can be indexed with a key field and sorted. It makes sorting this very efficient, sorting, joining, pulling, and so forth. It allows for very, very large capacity file storage. And your data can be stored in a highly indexed structure for quicker access. I've worked with databases before that trying to pull data from them took 3 or 4 hours without an index, and when you use the index, it takes 10-15 minutes. When you access binary files, only a portion of the file contents can be loaded. You don't have to load the whole thing. Some of the things, the cons here, are that the data files can be very large, and when data files contain an index, you require more file capacity to do this, because when you create an index, it actually is a separate file, independent of the original file you indexed. So you have a file that's 100 terabytes and you create an index, it's going to be a second file to act as the index for this. And it can be very, it can take a lot of space. Here are some examples of file extensions you can go read. So data in these data structures, ASCII or binary, can be accessed using SQL code. And this stands for the Structured Query Language. You hear this pronounced as SQL or something like this, or SQL. It's used throughout the data processing world. It's been around for a long time. Everybody uses SQL. Here is a course on writing SQL. I would highly recommend, if you're going to do this in your business life, to go through and look at that course, work through it, because it can be very helpful. There are basic elements and statements to the SQL language, and it has to go in this order. For example, the first statement is always the select. So what variables do you want to retrieve from the database? The second one is from. It designates what database source name is. A where statement is a delimiter, a filter, that's going to tell you which records are going to be brought into this data. You may be grouping. So you might say select sum of all, or average of miles per gallon when you group by cars. And that will calculate an average by cars. Now, all of this, the first steps here, select down to group by, those are used a lot. That's probably used 80-90% of the time in SQL coding. All of that is going to bring the data into a temporary file for you to work on. The having statement is going to be a filter or a delimiter that's going to work after the data has been brought into the temporary data set. So it will calculate a bunch of things, and then it looks at the entire data set that has been created, and you're saying, I only want to keep these from the data set. These are required. The first one, select down to group by, are required. The not necessarily where all the time, but the where and the group by and the having, they are optional. A very important aspect in the SQL is the join function. A join is used to link data structures together or to delimit a filter. There are different types of joins. I would highly recommend that you read this on the joins, because there's inner joins and outer joins and left joins and right joins and lots of different kinds of joins. Please read this. For example, there's a data table called cust data. It has 100 million records from a customer transaction database. Data has a listing of customer records, and you wish to extract data only in the state of Colorado. So you don't need to pull data from all 50 states. Just the state of Colorado is all you're looking for. So you can say select cust data. The asterisk says all. There's different formats of this. You're going to select that from the cust data set, so it's looking at this and it's the same name. But you have another data set out there that has a customer list. So the inner join says I'm going to join the customer list data set, and you have to tell it what I'm going to join it on. There has to be a common field that is in both data sets. So that common field is customer number. So I'm going to say, look at my 100 million records, and I'm going to first go through my customer list, and I'm going to join on this customer number. And my where statement says, from my customer list data set, where state equals Colorado. What that will do is it will delimit that 100 million records down to just the records that have a customer number from Colorado. Very important part of data is called data about data, and that is called metadata. It describes and gives you information about the data that resides in the file. Here's an example of a metadata set taken from SAS. It tells you what the variable name is, it tells you the variable type, the length of it, and if there is an embedded label for this. So here's div, it's a character, 16 characters in length, and this is for the league and division. Excuse me. Metadata should also include some information about foreign keys. Foreign keys relate to the information that illustrates how data from one set links to another one. Going back to here, here's your link. The two are linked by cust_num. They actually are the same variable name in both sets, but they don't have to be. Now, importing data is very important because you have to have the data in the SAS world so that you can analyze it. Data resides in millions of different places. Most of you have access to tons of data in your own corporation. You can find a lot of data publicly available in the St. Louis Fed.org. Tons of economic data is there. I'm sure probably some of you have used this data before in other classes. And important as the quality of the data is your metadata. Excuse me. This is data about data. You just mentioned this earlier. It's also going to tell you about fields that are indexed. So if you join or sort on an index field, it is going to run much more quickly. So there is a data set called baseball, which is located under the SAS folder when you log into SAS. And here is a particular procedure. SAS operates by procedures. So there is a procedure called data sets that gives you an idea of what the procedure does. I have to identify the library as SAS help, which is saying I have a big folder named SAS help, and I need to look in that folder for a data set called baseball. And the procedure data sets has a command called contents. So this is the syntax, the coding syntax. When you run it, it will look like this. So loading data into external files. So if you're going to load worksheets into SAS, there's a couple things you need to do. You start SAS and you follow these steps. These steps will work for most versions of SAS. If yours looks a little different, let me know and I will make the revisions. So I'm using the Enterprise Guide because it's my favorite. So I have Enterprise Guide open. I select File. I select Import Data. Now that we're using this new tool, you'll have to maneuver through this to find the data on your local computer, not the server farm. And here's one I'm going to load: colleges and universities. A lot of these data sets are stored under your resource folder. So I select this, I click Open, and it will start the import wizard. This is step 1. We'll tell you that it's the local file system, which means it's on that system. The file path that tells me where I looked for this. The data type is Excel workbook. The output is going to be local. The library is called work. Now, here's something that you need to know because you can very quickly and easily mess up. The work library on SAS is temporary. If it is only available while you have SAS open and running. If SAS is closed and you go back and open it up, your data is going to be gone. You have to save your data set in a permanent SAS source. And I've got some discussion to show. So you click Next. Step 2, it's going to say select your data source. First thing is data. If you have data in the first row that contains the field names, That's how it should be. Then I would click that. You have to click that. Some of your data values, the variable names, might have spaces between the words, and that kind of messes SAS up. So I would also recommend that you rename columns to comply with SAS naming conventions, and select Next. Step 3. It's going to read part of your data in, and it's going to create what it knows to be the source name, the label, what type of variable it is, the input format, the length, the output format, and so forth. So you're going to have an output format and an input. You also have an output in formats. It's kind of something that SAS does. Now, when you read your data, take a quick look at this, because you can really save yourself a lot of time here. Let's say, for example, that for some reason when I read my data, it came in and it said my math SAT score was a string. Well, you would look at that and say, no, that's not right. So then you could click on this part right here where it says number, and there will be a drop-down arrow, and you can change the format. This is especially important on dates. Most date times on the SAS input comes through as a string, and you will want to save this and change this value to a date time, or just date. And you click Next. I really never select these, but if you want to read up on them and see what it is, that's fine. Then you click Finish. So this is going to open up your data in SAS in the Work folder. Now there's a log window. You need to look at this, and it will tell you this is my output name. So if you go under the Work folder, you're going to see this. Because the name had spaces in it, you have to reference it using tick marks and put an N after it so that you can read that. Personally, I go through and I'll put an underscore in here or just take the spaces out, and it's a lot easier to work with, but that's just me. Your work folder is called, your temporary folder is called Work. Once you log out, it's going to erase. So the three parts of the work area are the project tree, server list. This is where you will find your folder, work, and permanent ones, and the output log. So in this, you have your project tree. It will show you what you have loaded. Here's your inputs, your imports, and then under programs, these are the programs that you create to write code and so forth. You can create a new code by selecting the highlighted icon here, and then select Program. And when you do, it will create that program under the Programs folder. Your server list contains a list of temporary SAS libraries, the work, and any others that are permanent. Any other library outside of work is permanent. Permanent libraries are not going to be erased when SAS is restarted. So if you want to keep a file that you've imported, you need to create a permanent library to save it there. So here under Work, this is the folder that we just accessed, the work. Here's the file. If you shut SAS off and come back, this will be gone, and you will have to re-import it. It's a real pain. So you can create a permanent folder and store it there. If you look at the log is really important. It tells you what you read in, the name of the output. It will give you some internal SAS code that was used to read it. It's kind of important to read that if you need to. Here are some variables. For example, this one's called the Math SAT. Since we did not select rename to SAS formats, you see that it looks like this. Okay, log window. When you go to the output window, which will automatically open, this tells you this is your data that you just imported from Excel, and it's in SAS. So now you can analyze the data using this particular data, not the Excel spreadsheet. Okay, let's say that you want to create a permanent folder. Typically, this is what you would have to do. You might have to play around with this since we're on a server farm. as far as determining what this actual folder name is. But you use a SAS command. I always use DB because it means database, but you can use pretty much any name that you want here. In the tick mark says on the C drive under a folder called temp, that's where I'm going to store this. You can use some SAS code to say data, it's a data step, DB referencing this permanent library. Here's the name, my SAS file name, and I can set the work, whatever my SAS file name is, and it will save a copy to the permanent data set. So to read data from a corporate database, you need to know a few more things about your data. Reading data from a corporate database is not like importing from a file for two major reasons. One, the data in an Excel file is limited to a fixed number of records, like there's a 65,000 row limit on earlier versions of Excel, and the number of variables in a column, how wide the file is. So reading data from a corporate data warehouse database is based on accessing the data, probably through a code like SQL, to retrieve the data. This data can then be stored in a flat file. The data can also be accessed and fed into SAS. So here's an example using SQL. I'm going to read the database named Finance, and my table is going to be called Billing, and my fully qualified name is finance.billing. Or it could be finance.dbo.billing, where DBO stands for database object. Remember the different components of this. Select and from are required. The other ones are not. We talked about the join before. So here's an example. Before you attempt to download the data, you don't want to say, show me all the data. You may want to say, show me the top 3. So you use a select statement. This is a parameter, top 3. The asterisk says, give me everything from that database. And it will retrieve the 3 records, period. Suppose you want to return the variable names listed here and billing amount for the database for the year 2014 might look something like this. Select variable name, comma, and so forth from the finance billing, where billing date is between 2014, January 1st, 2014, and December 31st, 2014. One thing that you need to know is what is the date format in that database. If it is, this is the correct format, you're fine. If it's not, you're going to get an error. So suppose you want to return the variable names, merchant ID and name, billing date, and so forth for the year 2014 for merchants in Colorado. This is what we saw before. Might look like this. Select merchant name, A period, merchant ID. So I called the first data set that I have here, I gave it a file reference of A. So it's going to get a merchant ID from A. The billing date, there's not a billing date in both of these. It will go to the one that has it and put it here. Invoice date and billing amount. You're going to select that data from the billing data set of finance. You're going to do an inner join like we did earlier. The join field is called merchant ID. Notice I put in inner join finance DBO merchant address B. That's so that I can reference this. I'm going to pull the merchant ID from A, and I'm going to set it on the merchant ID from B, where the billing date is between this. Okay. That is not going to give us all of the Colorado until I put something else in here that says and state equals Colorado. So we need to add a little bit more to this. A couple things to note. When you introduce another table, you must reference it with a reference name. I used A and B above. In your select statement, you must reference what table you want to use for extracting the data common to both. That was the merchant ID. Suppose you want to return these variable values and sum of billing amounts from the database for the year 2014. Now we're going to do something a little different. I want to select the merchant name, the merchant ID. I have a function, a statistical function called count. I'm going to count the number of invoices, and I'm going to name that new variable invoice in. Then I'm going to sum the billing amount, and I'm going to call that a new variable called amount sum. I'm going to pull that from the finance, the billing data set of finance, where the dates are between here, and I'm going to group by merchant name and merchant ID. That is going to show you merchant name, merchant ID, then it's going to count the number of invoices and sum the billing amounts for the year 2014. Now that's native SQL. You can use SQL statements in SAS. So in SAS you can read data using any of the four methods. Import, you can use a live name, you can use an SQL interpreter called, for the procedure, ProcSQL. There is an option on the SQL that does not use something called the pass-through functionality, and then you can use one with pass-through. We'll get to that in a minute. So let's say that you want to import. So you have to import your data. You need to store it in a permanent SAS library. I've imported data into Work Billings. I want to store it in a permanent SAS data set. Here's where I put it. You can also use the combination of this live name and the ODBC driver to say that I'm going to pull data from a ODBC source, maybe an Oracle table, and I'm going to say, call it my lib. ODBC is an option here that says I'm using the ODBC functionality. It's going to pull the data sources, let's say it's a Oracle table, my data source. The password and user ID are here. When you tell SAS to go get data using this, you're going to pull all of that data in, and it's going to take a long time, a really long time. So that's why we have the pass-through and the no pass-through choices. So I can use something like this, and this is very similar to what we had above. So it's going to be very time consuming. Or, and I know this looks really weird, but it's the pass-through. So it says ProcSQL connect to ODBC as mycon. That's the name of your connection. Username is Smith. Password is whatever. The path is the name of your Oracle server. And then it's going to say bring everything that is retrieved back from the connection to mycon. This information in between is native SQL for Oracle. So it's the Oracle's version of the SQL. You have to make sure that your syntax matches the Oracle syntax within here. So it will go in there. It's going to pull that data for just that year. It's going to bring it back to you. Now, you can use this to delimit what is going to be brought back, and it works a lot faster. So, I talked about the inner portion. This is the native Oracle SQL. The outer portion is SAS. So, this is where your inner portion goes. So, you have to make a network connection, transfer the SQL code from one inner portion to the native database environment. Then you can retrieve the process information back to that device. Then you must disconnect. If you do not put in the disconnect, it will leave that session open, and that will cause a database administrator to give you a nasty call or shut your sessions. So always disconnect. Any filters, subsetting, whatever that is done within on that inner portion here, that means only the filtered data is extracted back to SAS. So you need to do all of your filtering, all of your sorting, all of your grouping within this inner portion so that the only portion that comes back to SAS is the final filtered amount. Okay, that is the end of this week's lecture, lecture notes. Good luck on your homework, and if you have any questions, of course, shoot me an email. Thanks a lot.